Hello, Flat Earth researchers, debaters and debunkers. Hard-headed heliocentric fanatics with an atheist agenda have great difficulty in perceiving the relationship between the Earth, Sun and Moon as being anything other than having us living on a physically impossible spinning ball Earth whizzing around the Sun at thousands of miles an hour. And they will insist that the heliocentric model is the only way that you can predict events in the sky such as solar eclipses, as we can see here, that occurred on the 26th of December 2019 on this day and night world map on timeanddate.com, which is a very accurate source of making predictions and seeing the path of the Sun and the Moon at any given time or location on the Earth. And of course here we do not have to have an Earth that is moving. So this official source here is an excellent illustration and demonstration of how you do not have to imagine that the Earth is a moving sphere or rotating sphere in order to be able to make predictions or track the paths of the Sun and the Moon. In fact, I've never ever seen an anti-flat earther or globe-hugging believer come up with a globe and a sun and a moon in order to make a prediction for an eclipse, even though they insist that it's the only way that you can make these predictions. The fact is that the Sun and the Moon follow regular paths that are predictable regardless of the shape or dimensions of the Earth and where the Earth is assumed to be in relation to the Sun and the Moon. And it is those predictions that can then be translated into various kinds of models. You could put the Moon at the center if you wanted to, and you can put the Earth at the center. Either way, you're just finding a way to illustrate the passage of time and illustrate the predictions that are made from earthbound observations, regardless of whether the Earth is moving or not. So let's start with the 26th of December at midday Phuket time when we had the solar eclipse, and we'll go through this moving one day at a time, and we'll see this map illustrate exactly what we see in real life. And what we see in real life is we see the Sun pass overhead and we see that followed by the Moon. So we can interpret it as the Earth being stationary with the Sun and the Moon moving overhead. Now, of course, when you do an illustration like this, you'll get these kind of straw man arguments come up, and they'll ask questions such as, well, how does the Sun and Moon stay up there? Or why does it have a 24-hour sun in Antarctica? Well, that isn't necessarily the point of doing an illustration like this, and this is not a definitive model of the entire mechanics of the Earth and the universe. It is simply an illustration to show the passage of time and the passage of the Sun and the Moon above a stationary Earth. So if we just go forwards one day, what's happened is the Sun has crossed the sky, and so has the Moon, but now the Moon is slightly behind the Sun. So you'll see the Sun come up at midday at its zenith for Phuket, and the Sun will be a little way behind it. The Moon will be a little way behind it. So what we have now at the moment is a daytime Moon, and as you can see, as we click through the days, the Sun and the Moon get further and further apart. Now I will illustrate after this how we can put this into an azimuthal projection from the North Pole at the center or the South Pole at the center, and just talk briefly about what an azimuthal map actually is. So as we go forwards, we're now on to December the 31st, and we see a larger gap between the Sun and the Moon. And we'll also see that the Moon is coming away from the path of the Sun and moving up north slightly, and it will continue to do this throughout the month. So now it's gone over to, the Moon has gone over to the other side, but that's basically just because the gap is widening between the sun and the moon. And now we're getting into the point where we start to see the moon come up at night. And this would be the same for any location on the Earth. So again, it's midday for Phuket, and we wouldn't see the moon come around until the evening. All right, so we just carry on going forwards like this. So once we get to about halfway through the month, then on a circular projection, the sun and the moon would be opposite each other, and that's when we would see a full moon as well. All right, so we'll just carry on doing this, and in a second I will show you how this appears as a series of events on a single map. But let's just go through this, and we can see now that the moon has now moved up to this northern latitude while the sun has remained there. So does that mean that the Earth is wobbling to have the moon appear above different locations, or is the moon doing something? Who's to say what is actually moving? What of course we do not ever have is any measurable proof of the Earth actually moving, and it seems pretty obvious that it's the sun and the moon moving. Again, regardless of the mechanics of it all, what we're doing here is simply showing how this official source at timeanddate.com illustrates the passage of the sun and moon without having to move the Earth. So we're up to the 22nd of January now, 2020, and basically what's happening here is the sun is now effectively catching up with the moon. So we're back into having a daytime moon, but the phase of the moon will be different. We're approaching a new moon, so this will be in a waning phase. All right, so now we come to the 25th of January, and let's just make it a complete month, the 26th of January. So that's 1 month after the solar eclipse on the 26th of December the previous year. And we can see that now, of course, the sun and the moon have come more slightly apart. It's quite simple. There's a way to predict where we will see the sun and the moon at any given time. So what I've done here is I plotted, it might look a bit confusing, but I basically went through an entire year. So all of these spots are where the moon appeared throughout each month until we got an entire year. So you basically have these different colors representing each month. For example, you might be able to see the yellow one there or the black one there. So we have this kind of wave effect, and we can see, of course, that this would mean that the sun and the moon never quite meet until some predictable point in the future if we are also tracking the path of the sun. So again, this doesn't require that the Earth is a rotating sphere in order to make the prediction as to where the moon will appear at any given time or location above the Earth. So what we can do here is just turn this into an azimuthal projection, and what I've done here is changed it into a South Pole projection. So we have Antarctica in its entirety, and we can see here in this particular projection that we do have daylight covering the entire continent of Antarctica, and so this is how you can get a long extended period of daylight in Antarctica. But we can see how the moon is now doing circles above this particular projection, and we can also see that it's kind of doing concentric circles throughout this entire year. For example, you might want to follow the black one there, and it's kind of off center, and then the yellow one, for example, is all the way over here off to the left. And again, we could also do a projection from the North Pole, and this is what that looks like, where we have again these concentric circles. So really you can illustrate this any way you like. And of course, with an azimuth projection, what we're actually doing is choosing a reference point that we assume is where we are locating ourselves on the Earth in order to make a projection. So of course, the farther away you are from the center, the wider everything will become, simply because of perspective. Because the farther away something is, the smaller it gets in our vision. So 1 degree or 1 arc second or 1 arc minute translates into an increasingly wider angle over distance. And that's all an azimuth projection is. It is simply choosing a point from which you intend to make an observation. And of course, from that point, everything in the distance is going to become smaller and become part of a wider and wider field of view. That is all an azimuth projection is. So let's just look a little bit deeper into this claim by the spinning space ball believers that only a heliocentric model can accurately predict eclipses, whether they are solar eclipses or lunar eclipses and other celestial events that we see going on in the heavens. And we'll see from just a little bit of independent research without repeating and regurgitating consensus from the atheist agenda that you can in fact predict eclipses without having any knowledge or making any assumptions about the shape, dimensions of the Earth, or whether the Earth is a sphere and it's spinning around the Sun. A heliocentric model is certainly not required to make these predictions. So anyone that tells you that it is the only way to make the predictions is frankly lying or just being ignorant and haven't done their own research. So here we have this article, Atlas Obscura, How to Predict an Eclipse Without a Computer. And it says here that humans have been predicting solar and lunar eclipses for almost 2,000 years, long before they knew what exactly was happening or why it is meaningful. These days we have a pretty good understanding of when they'll take place. NASA has plotted out every single one for the next 1,000 years or so, and the previous 4,000. But if you don't want to rely on the experts, what are your options for predicting a solar eclipse yourself? And it just comes down to counting. Perhaps the easiest way to predict a solar eclipse doesn't require any sophisticated knowledge of the universe whatsoever, just the ability to watch and to count for a long time. In fact, people have been watching and counting, making calendars essentially, for almost as long as they farmed the land. Every organized, agriculturally based civilization develops a calendar, because that's what you need to determine planting times, says Raymond Lopez, a space physicist at the University of Texas at Arlington. And he in fact says that you do not need a heliocentric model. You just need to know rising and setting times of various models in the sky. Various models. Okay, so again, it's all down to calendars. And as I've said before, the heliocentric model is nothing more than an illustration of the Gregorian calendar, which is a solar calendar. But these predictions can be made regardless of what kind of calendar you wish to use and regardless of what kind of model you wish to use. So here it says that ancient people may not have known that the Earth is round or spinning or orbiting the Sun, but once they started recording when things happened, they began to notice patterns. One of the clearest patterns for predicting solar eclipses is the Saros cycle, first observed by the ancient Mesopotamians. Within a Saros series, solar eclipses occur at intervals of 223 lunar months. These cycles each last around 1,000 years, eclipse after eclipse after eclipse. So there is the predictability from which any kind of model can be created. And again, whether you're following a lunar calendar or a solar calendar, it doesn't matter. You still end up with the same results. It says here, unfortunately, the subsequent Saros eclipses don't happen in the same place, but 1/3 of the way around the Earth. It takes 3 Saros cycles for an eclipse to recur in a similar place as the first one, approximately 55 years later. And here we have some Sumerian tablets that are said to be related to these astrological predictions. And of course, there is not a globe or heliocentric model in sight. This is the so-called Venus tablet of Amisaduga from ancient Mesopotamia, and it shows detailed astrological forecasts. And a little further reading on Babylonian astronomy on this wiki page reveals some more evidence that we do not need a heliocentric model to make predictions of eclipses and other celestial movements. Here under the section about cosmology, it says, in Babylonian cosmology, the earth and the heavens were depicted as a spatial whole, even one of round shape, with references to the circumference of heaven and earth, and the totality of heaven and earth. Their worldview was not exactly geocentric either. The idea of geocentrism, where the center of the earth is the exact center of the universe, did not yet exist in Babylonian cosmology, but was established later by the Greek philosopher Aristotle's On the Heavens. In contrast, Babylonian cosmology suggested that the cosmos revolved around circularly, with the heavens and the earth being equal and joined as a whole. The Babylonians and their predecessors, the Sumerians, also believed in a plurality of heavens and earths. This idea dates back to Sumerian incantations of the 2nd millennium BC, which refers to there being 7 heavens and 7 earths, linked possibly chronologically to the creation by 7 generations of gods. No mention of a globe there, or a heliocentric model. There's some information about astrolabes there, and some information here about the relationship of calendar, mathematics, and astronomy. So the exploration of the sun, moon, and other celestial bodies affected the development of Mesopotamian culture. The study of the sky led to the development of a calendar and advanced mathematics in these societies. The Babylonians were not the first complex society to develop a calendar globally, and nearby in North Africa, the Egyptians developed a calendar of their own. The Egyptian calendar was solar-based, just like the Gregorian calendar, while the Babylonian calendar was lunar-based. Okay, so here we have the Babylonians making predictions for eclipses and other celestial events, and they had a lunar-based calendar. Does that mean that they assumed that everything is revolving around the moon? No, they just made the observations, kept the records, and from that they were able to make the predictions. And so it goes on. A potential blend between the two that has been noted by some historians is the adoption of a crude leap year by the Babylonians after the Egyptians developed one. The Babylonian leap year shares no similarities with the leap year practiced today. It involved the addition of a 13th month as a means to recalibrate the calendar to better match the growing season. Babylonian priests were the ones responsible for developing new forms of mathematics and did so to better calculate the movements of celestial bodies. One such priest, Nabu Rimani, is the first documented Babylonian astronomer. He was a priest for the moon god and is credited with writing lunar and eclipse computation tables, as well as other elaborate mathematical calculations. The computation tables are organized in 17 or 18 tables that document the orbiting speeds of planets and the moon. His work was later recounted by astronomers during the Seleucid dynasty. All right, again, so no mention of a heliocentric model or an assumption that the Earth is a spinning ball. But as you can see here, it was the mathematicians that were given this priest-like status, and this is exactly what we have today with the Neil deGrasse Tysons and the Bill Nye, the science guy. They simply repeat these calculations that have been made for millennia and tell us to associate it with this heliocentric model. And then of course you have these globe believers assuming and insisting that only a heliocentric model that was developed just a few hundred years ago can predict eclipses. So, of course, what is happening here is they are showing us that they are either being ignorant, intellectually lazy, unwilling to do their own independent research, and simply wanting to uphold a lie in which they would have us believe that the heliocentric model is the one and only way that you can make predictions. When anyone can do this research, check the facts for themselves, and see that this simply isn't true. So with that, I think that's enough food for thought, and I'll thank you very much.
Click subscribe and the bell icon if you'd like to receive notifications of new videos from Phuket Word.